Hello, this is Mr. Martin. This is a video solution for an inductive proof from the inductive proof practice worksheet. This is going to be for number 3. Number 3. All right, so we had 27 plus 81 plus 243 plus, and then 3 to the n plus 2 as our nth term, and this is equal to 3 to the third times 3 to the n minus 1 divided by 2. So a lot of times the hard part about these inductive proofs is really just the algebra manipulation in step 3. But usually if you stick with it, you'll figure it out. So for step 1, we want to show true for our value of k is equal to 1. So we've got 3 to the 1 plus 2. We're going to plug 1 into that, and we want to show, don't forget your question mark here because we don't know that it's equal yet, 3 to the third times 3 to the first minus 1 over 2. And we get 3 to the third on this side, which is 27. And on this side, we're going to have 27 times 2 divided by 2, so that's also 27. So we've shown it true to for k equals 1. Now for step 2, assume true for s sub k and show also true for s sub k plus 1. Alright, now in step 3, I might have mentioned this in another video, but make sure you're not using n in this step because n is the general variable we've used in the formula. K is a specific value, like a number, the number k. It's not the general value for n. So we're going to show it's true for s sub k plus 1. So I've got 27 plus 81 plus 243 plus plus 3 to the k plus 2. And then we're going to go one more to k plus 1. So 3 to the k plus 1 plus 2. So we plugged in for k, and we're assuming that that's true. And then we're plugging in for k plus 1. And we want to show that that's true for, so 3 to the third times 3 to the k plus 1 minus 1 over 2. Okay, so again, make sure you use a k, make sure you have a question mark here because we're trying to prove that these two are equal. All of this here is s sub k, and we're assuming that's true. So s sub k is 3 to the third times 3 to the k minus 1 over 2. All right, and then we have this term here, so that's plus 3. Now I'm going to split this up a little bit. So it's k plus 1, and then that's plus 3. So I'm going to make it 3 to the k times 3 to the third, because this term here is really k plus 3. So instead of writing it as 3 to the k plus 3, I'm going to write it as 3 to the k times 3 to the third. Alright, and over on this side, we'll do a little simplifying over there. 3 to the third is 27, so we'll just make that 27 times 3 to the k plus 1 minus 1 over 2. Alright, so in the next step, again, I'm just going to do a little algebra algebraic manipulation here, this is going to be 27. And then I have 3 to the k minus 1 over 2 plus, and then I want a common denominator here. So I'm going to multiply this by 2 over 2. So 3 to the k times, we could just make that 20, let's leave it as 3 to the third. And then times 2 over 2, because we need a common denominator. Now, I'm going to do something a little bit strange here. I'm going to change this 2 to 3 minus 1, and you'll see why I did that in just a second. Alright, so next I've got 27 times 3 to the k minus 1 over 2 plus, there's my 27 over there, 3 cubed is 27, times 3 to the k times 3 minus 1 all over 2. Okay, so I just rearranged over here. That's my 3 minus 1. And now what I'm going to do is I'm going to distribute over here. So we've got 27 times 3 to the k minus 1 over 2 plus 27 times, so I have 3 to the k times 3 to the first, so that's 3 to the k plus 1, and then minus 3 to the k all over 2. Let's put some parentheses here. Alright, and then each of these terms has a 27, so I'm going to factor that out. So I have 27, and then what I'm left with, since I have a common denominator, I can add the rest of the terms in the numerator. So 3 to the k minus 1 plus 3 to the k plus 1 minus 3 to the k. So I'm just taking all of these terms here and adding them in the parentheses here. And you can see I have 3 to the k and minus 3 to the k, and this is all over 2. And we're left with 27 times 3 to the k plus 1 minus 1 over 2, which is what we had up here, is equal to 27 times 3 to the k plus 1 minus 1 over 2. So it works. So the more you do these problems, the better you'll get at them. You know, again, just the important parts. Make sure you don't skip steps 1 and 2. I know they at times seem silly, but they're an important part of the inductive proof. And then also make sure you're not using n in step 3. So if you have any questions, feel free to email me or message me on the classroom, and we'll work those out for you. So hope you guys are doing well.